had the good fortune of receiving one of the first IBM PCs made in the year 1980 or 81. Somebody brought one back from the United States for us. And it was a revolution because for the first time, individuals could actually use a machine to do calculations, to print things, to design, to do so many tasks that till then could be only done with a typewriter or by hand. For those of you who remember, back when I went to graduate school, the bulk of computer processing happened either on mainframes that required you to do a lot of thinking, writing code, getting those converted to punch cards, and then get the punch cards fed into the machine when you got your slot, and then you'd wait for the program to run and give you back the output, and then you'd get the output like 6 or 8 or 12 hours later. That's what mainframe computing was like at universities, at research institutions. There was no email, there was no internet. Maybe there were mini mainframes like wax machines and the inception of desktop workstations on Unix like Sun Microsystems. This was late 80s. So we went through a few different revolutions, starting with the PC. In my opinion, another major revolution was the onset of graphical user interfaces, whether it was Apple Mac or the first Microsoft Windows release, I think in 1990. Because it truly democratized access where you didn't need to have learned a programming language just to operate the computer, let alone to do anything more with it. I think I was one of the first people to complete my entire PhD dissertation on a personal computer without having to go to any major text editing programs on a workstation. And I used, at the time I forget what it was, but it was a software that could run on a PC to format and actually, frame my entire dissertation of a few hundred pages with tables and graphs and whatnot have you. And then in my consulting days, I saw the advent of both thin clients and relatively then very sophisticated and very cheap analog to digital signal converters, which was the basis of the whole ERP revolution. For many of you who may not remember, it was only in the early to mid-90s that ERP solutions started becoming standard, right? I2 and things like that, long before there was the SAPs and PeopleSofts. So really, if you start with the notion of integrating physical activity to some centralized computer control or automation or planning or strategy or critical path, then the ERP revolution was the first major computerization of industry where you could start integrating all the way from your order book or your customer demand to how your factory should schedule production of what variant of what product. So this was maybe 30 years ago, mid-90s. Of course, connecting everybody together and creating the internet was another huge revolution in the mid to late 90s, leading up to the first dot-com boom and bust. And then we have had multiple comings of artificial intelligence. This is not the first coming of artificial intelligence. We've probably had 3 or 4 of them in my lifetime, where the neural networks and whatnot have you. And of course, now we have been in a boom since the age of social media. There's been, in many ways, a negative revolution or a deeply societally impactful revolution where you have started to create mini ecosystems of extreme views, and both society and politics as a whole has become greatly polarized. And I, for one, think that social media had a huge impact in the degradation of the quality of politics in most democracies. And I'm not the only one. I've been to a few conferences recently and I'm starting to see more and more people talk about this. In fact, I spoke at a conference in Delhi last week, right after our Imagine conference. I had to fly up the next day to keep a previous commitment, and the gentleman who spoke before me was the author of a book called The Outrage Machine. And it talks about how social media has created this rage in society because of continuously feeding the kinds of messages that are likely to invoke extreme feelings and anger and passion. And so, we have seen negative kind of innovations and revolutions as well. But if I think about two things, one IoT and two AI. Let's look at IoT first. In some sense, IoT is a progression of general purpose technologies that started with the notion of steam or electricity, which were useful in a myriad of applications and could effectively increase efficiency, increase throughput, increase economic value with the application of one general purpose technology across a lot of things. And IoT, at least in my kind of jaded view of the world, perhaps based on the many things I've seen in decades, is simply that we now have, instead of having an AD converter, get some kind of input, take it to some other place, process it somewhere else, and then send back some feedback or try and control the machine. Now we can embed that intelligence into the machine itself. We can have actually connected real-time systems with localized optimization and localized intelligence or localized programming inside the devices. So I don't need to wait for a machine to go and get integrated with other machines. The machine can A, take care of its own logic in its own embedded chip, B, talk to the two machines up and down the line without having to go to a central server and get optimized internally within this mini component of the assembly line of process, integrated process. In industry and infrastructure, this is likely to be only a gradual or a step change rather than a revolution. But in our daily lives, I suspect that if we really connected all our devices through these kinds of things like smart fridges and whatnot have you, lighting systems, heating systems, etc., I think we'll be seeing revolutionary outcomes, both in terms of efficiency, cost, as well as actually optimization of quality of life. It's not quite here yet, but my suspicion is that it's not very far away. Moving on to AI, as I say, this is the third or fourth or fifth coming of AI. The cutting edge of AI is very, very impressive, and it is in a different league now, because if I put that in context, my PhD dissertation going back to 1992 or 93 was about understanding how people think and trying to figure out how to make the machine slightly more user-friendly to people. So it was titled Individual Differences in Cognition and the Implications for Computer Interface Design. That was my PhD thesis, I'm saying late 80s, early 90s. Here we are 30, 35 years later. We don't really need to worry too much about machines. We now are designing machines to understand how people think and to actually act in a way that is natural for people to interact with. This major shift away from trying to get people smart enough to work with machines to making machines understanding enough to work with humans is really driven by, in my view, two core things. One, the almost infinite capacity to generate, store, analyze, and learn from data, which is not a small thing back in the day. Just to put that in context, I should also tell you, the first IBM PC that I got had 64 kilobytes of RAM and a 20 megabyte hard drive. 20 megabyte hard drive, right? That was the size of memory storage then. I think my phone has like a few hundred GB of storage. So you can see how much the world has changed. So this capacity to have, terabytes and terabytes of data instantaneously generated, analyzed, stored infinitely, in flash memory, because then you didn't even have the kind of storage devices that were that permanent. Those of you who are my age may remember floppy drives and mini floppy drives and whatnot have you. So the first engine of the AI revolution, this revolution, has to be the capacity to generate, store, analyze previously unimaginable quantities of data in many forms, not just text form, but increasingly voice as the medium of data and storage. And the second has to be the sheer computing power or the computing efficiency, transcending all the notions of Moore's law, the capacity to now, process information through what once used to be called supercomputers can now basically be hired on demand through the cloud by even a startup. And so your ability to get actual processing capacity has been democratized to some extent, and innovators can really get access to equipment that would otherwise cost hundreds of millions of dollars. So the good news is that if you're an innovator, if you're out of the box thinker, you can get access to these things much more easily and with fewer barriers to entry than there used to be. But there's some, reality checks we need to go through. At this point in the world, there are relatively few people who can make the kind of high-capacity processors like the GPUs. I just saw the earnings statement. How many of you saw the last earnings statement of NVIDIA? NVIDIA last quarter had record profits of $17 billion for the quarter, not for the year, for the quarter. Now we got a problem. If you need NVIDIA chips as the basis for any of your plans, I think the waiting list for supply is something like 3 years long. And big companies like the Microsofts, Googles of the world are just acquiring them like they're going out of style, partly because it's a roadblock to others who might otherwise come and compete in the business. So there is a serious supply chain constraint. Of course, there are many more companies who are coming up with competitive chips. This relatively monopolistic advantage will not last forever. But just to tell you, just because the cutting edge of the technology is at one place, doesn't mean that everybody has the capacity to do it at that scale continuously. I read somewhere that ChatGPT's, OpenAI's monthly cloud processing cost is something like $25 million, right? That's how much they pay for the processing on the cloud. That's one company, agreed, 100 million users or whatever, but still. So, though the leading edge of the technology might be very advanced, it's not nearly available to everybody, at least not steady state. The other thing is, even though we have such capacity to store and process data, and even though I would say in Tamil Nadu we are lucky, one of our most booming industries is new data centers for various reasons, it is still a far cry from the amount of storage that is going to be needed to really make this kind of technology available to a lot of people, and the amount of resources from electricity to cooling that are going to be required to make this happen. So, in my mind, we are still in the very early stages of this era, this S-curve, this transition. And I don't think it's going to come as quickly. Maybe the leading edge moves rapidly. Already we are starting to see some limitations in the leading edge and the extent of hallucinations and stuff that come out of ChatGPT. So I'm not sure that this leading edge will even move as rapidly for the next, let's say, 36 months as it has for the last 12 months. But even if it were to, it's not clear that it would be scalable because of the physical limitations, the infrastructure costs, and the access to the supply chain and the manufacturing of these devices. In a way, that's good, because what it does is it allows people like us, people who are rich in human capital, which Tamil Nadu is almost unlike any other place in the world, to tailor our education, improve our understanding